Okay, we're back talking about function notation and vocabulary. And I wanted to pause. We were doing some evaluation of functions. I wanted to pause to talk about relation just for a moment. What is a relation? A relation is a set of ordered pairs, x, y, where the x fellows, whoever they are, constitutes the domain, and the y fellows, whoever they are, constitute the range. Now, just because we have a function, or excuse me, a relation that makes sense, that does not necessarily mean we're talking about a function. And I saw an example in the OpenStax textbook for college algebra that looked like this. Consider this set, for example. Odd, comma 1, even, comma 2, odd, comma 3, even, comma 4, and so on. You get the idea here. Now, there is an obvious relation here. Sorry if I'm glaring you there. So yeah, every odd number that I've shown in these ordered pairs, these two at least, are indeed odd. And 1 is odd and 3 is odd. Same thing for the evens. 2 is even and 4 is even. But is this a function? Certainly it's a relation, but is it a function? Well, if it's a function, then for every one input, there is exactly one output. So recall, with a function, for every input, those are the x values, there is exactly one output. One output. Okay. So with that definition in mind, is this relation a function? I have to say no, it's not a function, because for the input odd, you notice that there are several outputs. There is 1 as an output, and there is 3 as an output. For the input even, there are multiple outputs. 2 is an output, and 4 is an output. So I'm going to have to say no, this is not a function. A function. Okay. Let me give you another example, also from the OpenStax textbook. Pretty awesome stuff, free, just download it, check it out. This is from the college algebra, but they have all kinds of stuff, math, science, many other things. There's something that has menu items. Okay, we're just looking at a menu for some restaurant or whatever. And instead of putting the same thing that they put, I'm just going to put item number 1 and item number 2, okay? Item number 3. We'll put 3 of them. And then over here I have a price section. And let's just make up a couple prices. I don't know, $5.89 and $6.23. Okay. And let's say that $5.89 matches up with item number 1 on the menu, and $6.23 counts for item number 2 and item number 3. Now there are a couple questions I could ask. I could say, is the item a function of price? Is the item a function of price? And by asking that question, I'm indicating within this little sentence here, this question, what is the input and what is the output? So the output is going to be our item and the input is going to be the price. So if I use I for item, let's say, let this be my function notation, I for item. I want to know, is the item a function of price? Yes or no? So for the inputs of price, do I get exactly one output? And the answer is no, this is not a function. How come? Because for this input of 623, I get two outputs, so that's unfortunately not going to work. However, what if I just rephrased the question and said, is the price a function of the item? Or of, I'll just say of item. It sounds a little weird, but is the price a function of item? So really what I'm looking at now is this question. Let's use P for price, big P, and maybe I'll still use the I in here, capital I. I don't like using little I because it just reminds me of the imaginary unit. So, question mark, is the price a function of the item? Well, in this case, I'm asking the question a little bit differently. I'm saying the inputs this time are the items, okay? So let me turn these arrows around this way. Technically two arrows there. So in other words, do I have exactly one output for every input? I put in this, I get out that. I put this guy in, I get out that. I put this in, and I get out that. Yes, this does fit the definition. For every input, I get exactly one output. So this one is yes. If I ask the question this way, the price is a function of the item. That is, if I give you the item, you can definitely give me a single price without ambiguity. So that's really relation. And that being said, I'm going to leave the relation question and definition here and move on to graphing some things and giving you a couple tests in reference to functions and domain and range and that kind of thing. So stay tuned.